Alright, so as we saw, a piecewise function is some sort of function that is created in pieces. So if you look at this, this is a piecewise function. It's got three different functions that are a part of it. Any point where, let's say here, so any point where x is less than 2, obviously our function is x squared. At x equals 2, our function is y equals 6. And then anything where x is greater than 2, our function is 10 minus x. So if we write this in our function notation, if I put my f of x up here, so it would be equal to x squared when x is less than 2, which is this part here. It would be equal to 6 when x is equal to 2, and it would be equal to 10 minus x when x is greater than 2. So if we get rid of some of these notes in here, we can see this is how our function would look, piecewise notation. Now what we want to notice is that this function is in fact continuous, because there is always a value for which, for x, there's always a corresponding y value. At x equals 2, the corresponding y value is 6. Anything greater than 2 would be accounted for by this function. Anything less than 2 would be accounted for by this function. So you can see there is always going to be a value for y for every x possibility. Now, if we had a situation where this point did not exist and we just had these two functions, then up until x being equal to 2, the function would be x squared, and up until x equals 2, the function would be 10 minus x. So at 2, you can see there would actually be no y value, so we would call this discontinuous. But since we have this here in the middle, this one would be continuous. Now if we look at a couple examples of function notation of our piecewise function and evaluating them. So a is asking for f of 1. So what we got to do is look at the function above. The thing we have to pay attention to is this second part. So the second part tells us that when x is less than 2, use this function here, and let me put in a different color. Use the blue function. And for when x is greater than 2, use the green function. So if I go into solving, f of 1, well, 1 is less than 2, so I'm going to use the blue function. So I'm going to use 2x minus 5, and my x value is a 1. So I'd have 2 times 1 is 2, minus 5 would give me negative 3. I'll do the same thing here for b. My value is 2. So if I look at this, 2 is greater than or equal to 2, so I'm going to use the bottom function. So I will have 1/3 times 2 plus 1, which is going to give me an answer of 1 2/3. And then c, I'll do the same way. My value is 3. 3 is greater than 2, so I'm going to use the green function. So I'll have 1/3 times my x value, which is 3, plus 1. So 3 times 1/3 is 1, plus 1 is going to give me a 2. So that's how I evaluate my function. Alright, so we've got my evaluated function. Now last thing we're going to do is graphing our functions. So if we're looking at this new function here, we can see that really what I'm going to call is my swing point or my pivot point, whatever you want to call it. The point that I'm looking at where I can see the functions are going to change is 1. So I know when the numbers are greater than 1, it's going to be using one of the functions, and when it's less than or equal to 1, we're going to use the other function. So what we can do is if we create this XY chart, we want to put 1 in the middle. And then let's go up 2 steps on each side. And we'll get a good idea of what the function looks like on both sides. So if we look at the top function, anytime that we have a number that is less than or equal to 1, we're going to use the function 2x minus 1. So for negative 1, we'll use 2x minus 1. We'll get 2 times negative 1 minus 1. 2 times negative 1 is negative 2. Minus 1 gives me a negative 3. And if I graph that at negative 1, I've got negative 3. There's my point. I'll do it for the next one, which is 0, because that's less than 1. 2 times 0 is 0. Minus 1 is a negative 1. Working our way up, we can see a little bit of a linear function going on there. And then the last one is 1. 1 is less than or equal to 1. So I would do 2 times 1 minus 1 will give me a 1 right here. So I'm going to have this linear function here. So we can see up until 1, this is what my function is going to look like. Now we've got to change, because now we got numbers that are greater than 1. I should be filling these in as well. So that was negative 3. This one was negative 1. This one was positive 1. So now we're going to use this one. So my function is now negative x plus 3 when x is greater than 1. So 2 is greater than 1, so I'll have negative 2 plus 3, which gives me a 1. And I'll have negative 3 plus 3, which gives me a 0. So I'll plot my points. 2, positive 1 is here, and 3, 0 is here. So we'll see this one's going to continue in that direction. So if I want to graph a piecewise function, what I can do is find this point. In this case it's a 1. This swing point or this pivot point. Put that in our middle and then find which function goes with which and evaluate those functions for a couple of your numbers. So it's really not too difficult. You just got to find what that pivot point is and then be able to evaluate your functions that follow.